So, Dr. Manduul, can you hear my voice?
Yes, hello. Dr.
Hello.
Yeah,
Hello. Nice to
nice
see
to
you
meet you.
again.
Yes, me
Okay,
too.
I will give a brief introduction of you, and I think you can proceed on after that. Thank you very much
Yes.
for accepting the lecture for our colleagues. Okay, hello everyone. I would like to start our lecture series for this week. And I believe some of your colleagues may be in Korea for the Asian Nuclear Medicine Board exam. So it's now ongoing for the exam. So I think there might be some participants in the venue for test. But still, we are going to have a lecture series. And I would like to introduce today's lecturer, Dr. Manduul. So Dr. Manduul is a nuclear medicine specialist at Second State Central Hospital of Mongolia, and he will guide us through the practical process of operating the cyclotron and producing radiopharmaceuticals. So centers that are actually planning to apply some new cyclotron can have greater interest in this topic. And he also recently visited Korea for short-term fellowship, so I also had a chance to meet him. So please welcome Dr. Manduul.
Okay, thank you, Dr. Min-seok. Good afternoon, professors and the participants. It's my great pleasure to welcome to all of you to TEIN Lecture Series 2022 this week. Thank you for the great opportunity for sharing our experience. Since 2021, in clinical field of nuclear medicine in Mongolia, the Our Center has been launched that the cyclotron-based FDG PET-CT at the first time in Mongolia. So today, the radiochemist, Miss Oyanga, she will be present the first experience in setting up radiopharmaceutical production and PET-CT in Mongolia. Thank you.
Good afternoon, everyone. I am Oyanga, the radiochemist from the Nuclear Medicine Department in State Second Central Hospital. So now I will share my presentation. Can you see my presentation?
Yes, we can see your slides.
Okay, so in here, so the subject of the presentation is first experience in setting up radiopharmaceuticals production and PET-CT in Mongolia. The contents of the presentation will be the introduction part, setup process of radiopharmaceutical production unit and PET-CT, F-18 FDG first production results, constraints we have faced, and future perspectives of our facility. So for the introduction, Mongolia is a landlocked country located in East and Central Asia. It borders with Russia and China. Our population is only 3 million people. And to mention, the first nuclear medicine department was established in 1975 at the first State Central Hospital. And it is the only hospital in the country that provides PET-CT diagnostic services nationwide. And the second department of nuclear medicine of Mongolia was established in 2021 at Second State Central Hospital. And this hospital will be the first hospital in the country that provides PET-CT diagnostic services. So to say about the nuclear medicine services that provide the first state central hospital, for the diagnostics of PET-CT, above the half of the scans is for bone scanning, and the kidney dynamic scan is 30%, and the other scans like MPS, thyroid scan, and the others are about 20%. And also the hospital provides the iodine 131 therapy, and 51% of it is for the thyroid cancer, and the rest is for benign thyroid diseases. So here you can see the equipments that we have. We have the cyclotron, synthesizer module, hot cells, dispensing machine, PET-CT, after injectors, and quality control equipment in our facility. We designed and prepared the room for the SPECT-CT equipment, but it is not installed yet. And about the equipment, I will present the detailed information in the next further slides. So the setting up process of radiopharmaceutical production unit and PET-CT started from the 2012 with the project proposal approval, and in 2015 September, the Exim Bank of Korea had approved the procurement contract. And also you can see in the next years the schematic designs of the construction approval, and also the construction of work has been started in the September. In 2016 December, the MOU between Ministry of Health of Mongolia and COFI-H to implement loan link assistance was signed. And the next year, the long-term training of the specialists of our facility has started, and in total 10 specialists were trained in the Kiramas, and also the Doctor Manduul has been trained, and this year 2 specialists will be also trained at the Kiramas. The next year, start of equipment on the on-site delivery. The equipments were delivered at the hospital. As you can see from the pictures, the cyclotron hardware and PET-CT hot cells installations were implemented from 2018 till 2020. As all we know that from the end of the 2019, the COVID-19 pandemic was spread worldwide, and it has made a lot of difficulties for all of us. Though the world countries have closed their borders, our government took an action to speed up completion of the project and granted permission to enter the country to the GE engineers for the installation and commissioning of the cyclotron, synthesizer, and PET-CT completion on special conditions. And the engineers were in quarantine together with our team to complete the installation and commissioning of the main equipment since September 2020. From this slide, you can see the installment process of the before mentioned equipments during the quarantine time. To emphasize from this slide, the first production of FDG was processed in November 5th of 2020. So the general considerations of the kits and daily expenses are the FastLab 2 cassettes are purchased from GE, and Timothy LD dispensing kits are obtained from Connoisseur. Enriched water was obtained from China, and the sterile product vials were purchased from China. From the table, you can see our results of the producing F-18 radioisotope. The average activity of the isotope at the end of the bombardment was 1,200, and we have 2 F-18 targets, niobium targets, to produce the radioisotope. So also you can see the cyclotron performance test and daily checkups shown in the pictures. This result is the synthesizing result of our first production of F-18 FDG. The radiochemical yield was 62%. It is not that high, but for us, for producing at the first time, it is, I think, quite enough number of the yield. We used the FDG single citrate cassette, and the date was 5th of November 2020. So let's talk about the radiosynthesis of F-18 FDG. I think you all know about the synthesis process, but I will just briefly explain the process. We use FastLab 2 automatic synthesizing machines. So basis is using the monostrip rate, and for the elution, the Cryptofix 222, sodium carboxide, and acetonitrile. We elute the. At first, we trap the F-18 radioisotope at QMA, and then with the elution process, we with the elution process, we put it in the reactor for the isotropic drying, and after that, in the monostrip F-18 goes to the desired position, and to remove the acetyl groups, we use hydrolysis with the sodium hydroxide. So after that, the finished product will be cleaned, purified with the TC18 cartridge and alumina N cartridge for not reacted parts, and also from the free F18 radioisotope. So from this slide, you can see the quality control tests, 9 tests in accordance with the United States Pharmacopoeia. So the first one is the visual inspection, then the pH metry. We also check the residual tryptophics, radiochemical purity, radiochemical identity, radionucleic identity by measuring the half-life of the radioisotope, residual solvent analysis, bacterial endotoxin analysis, and sterility after the releasing of the batch. So this slide shows our results of the 1 year of daily production of the F18 FTG. So as was mentioned before, the bombarding targets with a 30 microamp per photon beam for 1 hour produced 1,200, about 1,200 millicurie of the radioisotope. And from the table, also you can see that the non-corrected yield of the FTG using setup of non-corrected yield of the FTG were 822 millicuries. These results are the results for the 124 batches of the radiopharmaceutical, and the yield was 70%. So in our circumstances, under the technical and economical circumstances, the nearest and the easiest radiopharmaceutical to produce was sodium fluoride, not to mention the clinical effectiveness. So we are ready to produce the sodium fluoride, but sodium fluoride has not registered on the national medicine registration list. And this process consists of several official meetings and several steps of the registration process. So from the next slide, in the next slide, there is a cycle of registering the medicine in Mongolia. At first, we need to prepare documents, manufacturer site information, products quality assurance, accredited laboratory results, and etc. And next, we get an approval from the hospital and the Health Development Center of Mongolia, approval from Commission of Pharmaceutical Division, approval of Pharmacopoeia Committee, assessment by accredited expert from Health Development Center of Mongolia, and the finished parties approval of Mongolian FDA from the Council on Human Medicine. At the right, there is a scheme to get a production license. We also need to prepare documents at first and then design a project and get the approval from the hospital. And real-time check of accredited expert from the MOH checks our process, and assessment of accredited expert, assessment of MMRA. And after that, we will get the license of special permits to produce their radioisotope. And during the 1 year from the start of our operation, total of about 800 number of PET CT scans were performed. This year, we plan to perform 1,200 scans in 2023. In the case of F18-FTG PET CT scan, our center will point to neurological diseases, cardiovascular diseases, radiotherapy, and infections at the same time, scanning the cancer diagnosis by the first mission. Therefore, second PET CT was installed in our country, and we have the contract with that hospital to distribute the F18-FTG. So here is the brief scheme, the brief timeline of our 1-year operation from the equipment installation to the grand opening. At first, the equipments were installed, and secondly, government agency approval to operate cyclotron and PET CT was given, and GASI approval of radiation safety regulation was also given, and production license were obtained. F18-FTG was registered by Mongolian FDA, and the first patient scan was performed in July 2021. Our nuclear medicine department consists of 2 parts. One is the clinical area, and the second is production area. The facility was designed by IAEA recommendations of radioisotope using facility CGMP standard. And also it should be mentioned that 4 inpatient rooms specially designed for radioisotope therapy. In the clinical area, we have 3 injection rooms. As you can see at the right of it, the spectrum for the SPECT-CT, but we didn't purchase it yet. And at the bottom, in the center at the bottom, there is a PET CT room. The blue lined area is the clinical area. The green, the area that marked with green is production area. So let's take a look at our equipments more precisely. We have GE mini cooling cyclotron for the production of radioisotopes, 9.6 MeV of energy. We have 2 targets, niobium targets for F18, and 1 dummy target, 2 carbon foil. And also we have 2 hot cells, 1 for the synthesizer and 1 for the dispensing. And also in the facility, the transfer boxes were installed to implement the GMP standards. We have fully automated GE Fast Lab synthesizer, and also QC laboratory is fully equipped for radiopharmaceuticals, where it will be certified whether the specification of the final radiopharmaceutical product meet the requirements of the United States Pharmacopoeia. as you can see, B-scan TLC scanner, Scion gas chromatography, Capintec multi-channel analyzer, Charles Silver in the safe PTS, and 2 incubators. And last but not the least, Capintec dose calibrator. In the clinical area, there is an automatic individual dose dispensing and injection Carl 100 PET-CT system. It is GE's Discovery IQ with 16 slices of CT. And items for hot labs, hoods, dose calibrators, shields, dose drawing systems, and etc. So here is to emphasize that radiation protection and monitoring equipments are installed in the necessary points. And also technical gas room with leakage detectors is also installed. For every facility, the human resource is the most crucial part. So we have total staff of 13 people, cyclotron physician, cyclotron operator engineer, radiochemists, radiopharmacist, PET-CT technician, nurse, which are okay, so and also as mentioned before, 10 of them had completed special trainings at KIRAMS, except one radiochemist and one PET-CT technician, but they will go to Korea at this month to get the training. Due to the COVID-19 situation, we also get online trainings from the IAEA and KIRAMS experts. Okay. So about the constraints. In comparison with the well-designed projects of other countries, our project encountered problems and difficulties in construction and few equipment-related matters, and consultancy services during the implementation. Although the construction planning of the department was prepared under the general hospital planning, the structural requirements for a cyclotron facility and the radiopharmaceutical manufacturing facility had not been considered in the overall planning. As you can see from the list, the separate ventilation system for cyclotron, hot cell and QC and other areas, RI exhaust filters and detectors, differential room pressure system in the radiation control and production areas, pressure gauges, clean room and GMP requirements. RI transfer of trench from the cyclotron to a hot cell is not properly shielded. Technical gas room is not planned as per the regulation currently applicable in Mongolia, etc. And also the main constraint was for Mongolia, there was no certified expert experienced in the establishment of cyclotron and PET-CT facility sensors. And we considered that it was one of the reasons for omissions in the first planning of the project that resulted in postponed implementation. So we would like to emphasize that the expert of KIRAMS had played an important role in the successful implementation and completion of the project, though we had a large number of problems and difficulties. Here is the future plan of our facility. We plan to perform the F18 FDG PET-CT scan in from 1,200 to 1,500 patients in a year registered sodium fluoride, F18 sodium fluoride PET-CT to implement the sodium fluoride in clinical usage, meet the GMP compliance, expand radiopharmaceuticals, F18 radiopharmaceuticals beyond the FDG, and also to implement theranostics in our center, and to continue and expand the international cooperation. So for the conclusion, on-site cyclotron gives a great opportunity for producing diagnostic as well as therapeutic radionuclides. At the moment, training qualified and skilled professionals is a fundamental and essential task. In order to provide classified human sources, non-stoppable training, which can be supported by international cooperation with us, is vital. It lays the base for new opportunities that will provide an important impetus for the further development of the clinical and pharmaceutical fields. So thank you for attention. Thank you for your attention.
Okay, thank you very much. Dr. Manduul, do you have further comments, or could you?
So, first, thank you for being the part of this project, then including our facility. So now we are planning to the diagnostic, then such as the iodine therapy, but now it's still in under processing. I hope the next year we will be the procedure this treatment. Then also we would like to expand our radiopharmaceutical products such as sodium fluoride and the other tracers, radio tracers. And that's all.
Thank you. So if as a summary, could you really thankful for the lecture and your sharing your experience. So what might be the key strategy, or how did you overcome the constraints as you have mentioned? And is there any kind of your advice for centers who are actually planning to implementing the cyclotron? So Dr. Liang, could you share us about what might be the key strategy to overcome the constraints you have encountered?
Mm-hmm. So we had a lot of problems due to that. During the facility design, our department was not included firstly in the plan. So we just added in the project, and we solved the problems one by one slowly. And I think I think the advice is at first, it is crucial that it is better to design the facility that the design should be included in the overall hospital's construction design, firstly, according with the GMP standards and other IE guidances. But if you didn't do that, it is also better to have the experts' opinions, and to cooperate with the international experts to to take a support on these difficulties. And I think we would like to thank again the Kiramas experts that supported us in this project, and also Dr. Chimek, our head of the center, is a very she tried a lot, and she worked a lot to solve these problems, to connect with the international experts, and also to connect with the government organizations. I think the government organization understanding of the process and to, understanding of our process and to tell them our difficulties was the crucial part also of this project, because the budget will be given from the government. I think that's it.
Okay, thank you. So you are currently producing F18 FDG, maybe, and how many clinical is it? Sorry, I might have misunderstood, but so how many studies currently you're doing for the FDG PET?
Sorry, can you repeat how many?
Oh, so how many FDG PET studies you are doing currently? For like.
So, okay, Dr. Manduul will answer to this question.
Yeah, thank you.
Yeah, thank you.
Thank you.
Until now, we have around 800 patients performed the FDG PET. But it's the per week, we don't have a constant day. It depends on the number of patients. Around or 3 times per week we did. However,
oh no, sorry.
However, our experience is not so much. Now we are based on just the oncological patients. Near future, we would like to expand to another fields such as the cardiac and brain imaging. Yes.
Okay, thank you. So, so then, like, is it necessary for a GMP compliance to the production? Actually, you are already producing the FDG, so the GMP compliance is to supply other hospitals. So you have also plans to supply other hospitals for the FDG PET or other agents. So what might be the necessity for GMP certificate?
So we are planning to get a GMP certificate next year, because to have that certificate, 2 years of the data must be collected. And we planned our operation in accordance with the CGMP, and for the distribution to another hospitals, one hospital, private hospital, now has a PET-CT equipment. So we made the contract to distribute to them, and now we are distributing the FDG F18 just since May, and they take usually they take 6 patients activity per day, and they do not get it constantly, 1 or twice per week.
Thank you. So would there be other questions or comments from the participants? Maybe there might be centers who are preparing or undergoing for implementation of cyclotrons. So would there be any questions or comments? Okay, if not, I'd like to thank again Dr. Uyang. Did I pronounce it right? And,
Yes.
Thank you for your
Thank you.
Thank you for sharing your experience, and I really appreciate. So yeah, I think we can also share our experiences when you come to Korea. Okay, thank you very much, and
Thank you very much.
thank you for other participants for coming, and I think we can meet for the next session. Thank you very much.